I got it, don't worry.
Yeah.
And let's say negative 2x plus, oh, let's see. Yeah, this might be too freaky, Jeff. Negative 4. Okay. So the only method we have right now is the graphical method. So if I graph each of these lines, where will the answer be? So if I graph this line by itself, that's all the things that work on that line. If I graph the other line, that's all the things that work on that line. The answer is the point that works on both, so it's going to be where they cross, where they intersect.
So that's 5-2 on this one?
Exactly. Because if I graph both of those, wouldn't they meet at 5-2?
Right.
Yes.
So
That's
the
the
separate
idea.
lines? Yeah.
That is the idea. So what is an answer to a system of equations always? It is a, what physically? It is a point. Never forget that. The answer to a system of equations is a point. Or many points, possibly. So we'll see. So how do I graph those two lines? What method do we have to graph that the quickest?
Plot the.
If I look at number 1,
2y
Make x
is
0.
equal minus x plus 7.
good. So I can start solving.
Yeah,
Oh, did I really have to make this that evil?
minus x. Yeah.
Right, and then I can
Divide
divide
by
by 2.
Yeah.
Figure y equals negative 1/2 x plus 7 halves. I guess I did have to make it that evil, didn't I? It's a nice thing, Jeff. What about the second one?
Yeah.
Solve for y?
Y, 2x minus 4.
Okay, cool. Right? How are we doing so far?
How did that happen?
So you're doing the y-intercept and then the slope?
Exactly.
Oh, he added it.
Right? That's the quickest way to graph lines, is to solve for y and get the y-intercept and the slope. Now, I in a way, I'm kind of happy this happened because, yeah.
So when you move the y over, it doesn't become negative?
Where did I move? Oh,
No,
y.
he added it. He added 2x.
So here I subtracted x over,
X move.
and here I
X
added
move.
2x over.
Oh.
Yeah.
Okay.
Because the y's are already positive. I don't want to mess with them. Right?
Okay, cool, never mind.
Cool.
And then we have to the point where we can do an
So
x
what's
and
the
y
slope
table.
on this one?
Minus.
Down
Minus
1
1
over
over
2.
Negative 1 over 2. And the y-intercept, of course,
Is 7 over 2.
0, 7.
0, 7
Oh,
halves.
0,
Which
7.
is like 3 and a half. Right?
Exactly. Cool. Right. And the slope here is
It's 2.
2 over 1. And the y-intercept is
0, negative 4, right?
0 minus
0,
4.
negative 4. Cool.
You just made this one real complicated.
What's the only piece of this is that seems complicated?
When you put them both together, once you put the answer, you know what I mean, you should get the 2.5x plus 7 over 2 equals negative 4, and then when you go to divide everything out, once you get x.
Oh, you're getting a little ahead of me. I'm not doing an algebraic method yet at all. We're not doing algebraic methods yet. I'm just going to graph these bad boys. All right. That's the only method I'm talking about right now is the graphical method.
Physical. Like looking at the line.
Yeah. Now, to me, the only kind of ugly piece of this is to have a fractional y-intercept, right? So I'm going to show you something that's kind of cool, because of course that number could be anything. It doesn't have to be a nice, pretty whole number. So it's kind of good that I didn't mean to do this necessarily, but it's kind of good that happened. So let's give ourselves some scale here. So this y-intercept, like somebody said, is 3.5.
Yeah.
And the slope tells me to go. Now here's the cool thing. Let me see if you guys are with me on this. The slope tells me to go down 1 step and over 2, right? So for every 1 step I go down, I go over 2. I desperately want you to understand what I'm about to say. Does that mean if I took 2 steps down, how many steps over?
4, right?
4. Because for every 1 step down, I take 2 steps over. Isn't that the same thing as negative 2 fourths? So I take 2 steps down, I take 4 steps over. Because I doubled. So if I take, now I desperately want you guys to go with me on this. See where I am? I'm in a bad place here.
And the halfway.
If I take half a step down,
Yeah.
I take 1 step over. 1, right? A full step is 2 steps over. So half a step down will be 1 step over. Now I'm in a better place. Right? I'm hoping you guys see that. It's a really cool way to look at things.
Now you can just apply the regular slope to the new point.
Yes. Because now from this point, where can I go?
Down 1
Down 1
over 2.
over 1, 2. Down 1 over 1, 2. And I want to show you, you definitely want to count more steps off. How often is that going to happen to you? Probably not ever. At least not in this class.
Thank
But I want to
goodness.
show you, even if you're off by a fractional piece, just take a fractional step. Get yourself back to a nice whole number position, right? That position is, everything's whole numbers. I like it. Right? Just by taking half a step. If you didn't quite get that, okay. It's not going to always happen to you. You still do the same thing. You still got to count over more. Why do I want to count over more? Because if you just graph two lines,
Why just?
can you see where they meet really well? Probably not. Me, I definitely don't make perfect straight lines, right? Even if you use a ruler, your scale's got to be perfect. So why not count some more over? So here's this line. This is line number 1. What's line number 2? That's a little better.
0 minus 4.
Zero.
So I start at -4 and I go up
2 over 1.
2 over 1, up 1, 2 over 1, up 1, 2 over, holy shit. You see what I'm saying? So if you count each one more than you normally would, there's no question where they
4
meet,
times.
right? If I would have just counted down, where am I at? Down 1 over 2 and then just made a line, I would probably never see that it actually meets. I'd be like, where is that? Where is it meeting? But now I made it much more carefully. So what point is that?
Over 3 up 2.
4,
3, 2, right? 1, 2, 3,
Yeah.
1, 2.
So you do for the second equation, you go up 2 over 1 until you find the point that it meets.
Exactly.
Okay.
So graph one of them by stepping out more than you normally would. Do the same thing with the other one, and then eventually you're going to land right on top of one you already did. Yeah.
Until
Can you
it's
explain that 7/2 again? How you grabbed it and went down to half and step whatever?
Yeah, what, Jeff, what did you get on the first equation? What did you get for the answer on 1?
What, this here?
That's the answer?
no, it's 0 to 7 half.
Now you grab it.
No, okay.
No.
If you ask me what the answer is to a line, I can't answer that directly. The answer to this is here, right? Because how many answers are there? Infinite amount. So when you say the answer, I'm not sure what you mean.
Y,
The y-intercept was this?
okay, 0, 7 halves. That's what you get, okay.
Yeah. So, if I told you, if you take a step forward, you got to take 2 steps over. But the wall is half a step in front of you, right? So you can't take a full step, can you? So if I tell you go 1 step forward, you better go 2 steps over.
Yeah.
All right, if you're going to only take half a step over, you only went half that way, how far you want to go that way? Half as much as normal, right? So for every 1 step down, it's 2 over. If I only want to take half a step down, I better do half of what I normally would have done.
Oh, okay.
That's excellent. You can see that. That is the full explanation of slope. And really, if you guys think about it, it's like doing this. Isn't that still -1/2?
Yeah.
And what's the same? Rise, -1/2. So go down a half, go over 1. Right?
Well, I can't say down -1 and
True, but then I would have always been at the half point, wouldn't I? If I go down 1, I'm at the half point here.
yeah,
Another one, I'm still at the half point, right?
We can't.
I don't want to be at the half point.
we can't do it like
You
this.
can,
Yes.
but again, you'll be around this point, and you won't be able to see it as well.
Okay.
You want to put those dots right on those whole numbers. You can see where they meet, right? Now you can already start to see. The other good thing why this happened, the other good thing about this happening is the fact that you can already see why graphing won't always work, right? What if your answer is supposed to be 1.872, comma, -3.946? I am not going to get that out of a graph. I don't care how precise I make it, right? And my graphs are nowhere near precise, so I ain't going to get it.
So how did you know to switch, like, you got 2 over 1 there? Yeah. How did you know to switch that to a -1/2?
No, I didn't. This is all about this one. There's the first equation.
Okay,
So that's all about this guy.
okay.
I didn't switch any of it.
Yeah, you did. Right below it there, it says m equals minus.
This is all about the other equation. There's 2 equations, right? 2 equations. Here's one equation. Here's the other equation. They each have their own slope. They each have their own y-intercept, right?
Oh, you just wrote it up there.
So here's one equation.
Oh, I see.
Here's
what
the
you
other
did.
equation.
Okay, I'm
And
looking
I
at
work with
the,
each of them.
where you wrote -1/2 equals -2/4.
Oh yeah, right here.
That's what I'm looking at. Okay, I understand now.
Cool. Okay.
So, instead of minus half for the first equation, if you have minus 3/2, how you can do it?
Same way.
Say,
Yeah.
3
No,
over
three
2.
over
That one's gonna be,
So we got
1.5.
so that one you would go down like, so 3/2, you would go down a half,
Yeah.
and then you still have to go down a full step. That would be 3/2, right? 1.5. But let's not focus on that.
Okay.
In a way, I didn't mean for that to happen, but
Okay.
I want to make the equations work first. And I'm like, oh shit, that made an ugly y-intercept, but we still dealt with it. Fractions don't scare us that much. Are you gonna get this?
Yes, they do.
Yeah.
So back to number one at the very top. So when you divided everything by 2, it got rid of the 2, the y was alone, and then it turned it into 1/2 x.
Negative 1/2 x. Because it was a
If I
negative.
divide by 2, isn't there a 1 understood to be here?
Right. Okay.
Okay.
Got it.
So if I have x over 3, what is that really? Isn't that 1/3 x?
Right.
So I can see the slope better?
Right.
Yeah.
Okay.
Okay. So here, let me give you guys try this one. Let me give you one that's not gonna come out with a freaky y-intercept.
I'm scared.
I know. Scared. All right.
So you always solve for y first, and then you get the slope.
Exactly. The slope of y-intercept you plot it.
That's
Do that for each of them, right? Let's see.
minus 4.
Let's see.
That's the biggest challenge, getting something to work, huh?
And I'm trying to make this y-intercepts not be freaky too, so. What did I say? Okay, okay. Ah, screw it. That'll be fine.
So you can use either one to get your y-intercept, right? You gotta kind of choose which one is easier?
No.
No?
This line must be drawn. It's got a slope and a y-intercept. This line must be drawn. It's got a slope and a y-intercept.
But can't you get your y-intercept from the bottom one just as easily as you could from the top one?
But aren't they different? Because this guy has his own y-intercept, doesn't he?
Yeah.
And he must be drawn. He can't use this other guy's y-intercept, can he?
Oh, okay.
So they're each a line on their own right. So you're graphing one line, and on top of that you're graphing another line. So they each must be drawn separately, and then you separate and say, okay, where do they meet? That's the answer. Yep. Yeah, and now you can graph each of them.
Right.
Yeah.
So this is pretty much like y equals mx plus b. And then you get
You're just doing two of them at once. You're just doing two of them, right? Do one line, do the other line, and then step back and say where they meet.
Right.
So on this, the second one, you have to put the x and y in there. Just put different numbers.
So,
There's something for
That
number
was-
one,
That comes out to 3/1, this slope.
right, because you add the 3x over,
Right. And then you got y-intercept.
and then this guy, you subtract the x over.
So that's 5 minus x. Oh, yeah, I got it right the first time.
Oh, cool. Point. Look.
And of course, that's negative 1 over 1.
Yeah.
So now if you graph number 1, what's the y-intercept for number 1? 1.
3
Up 3
over
over
1.
1.
Wait,
So this one is 1, and then the slope is 3.
So we're at
Up
0.41.
3 over 1.
1.
Yeah.
I love it. And then if I went 3, 1 again, it'd be up there roughly. Okay. So what about the second one here?
It's gonna be
5.
5.
So start at 5, and it
Down
says
one
go
over
down 1 over 1.
So 0.41 is the answer.
Yeah. Well, careful.
1 4.
Yeah. 1 4.
Yeah, 1.
How do you check yourself?
Do a
By,
table.
Table, right?
just plug it in.
Yeah. If you plug in a 4 for y and a 1 for x, 4 minus 3 times 1 is 1.
One.
Plug in a 4 for y to